In this video, I'm going to show you how to create a drawing from the assembly of the caster that you've put together. What we're looking for is a drawing that looks like this. We're going to have a full section assembly drawing. We're going to have balloons indicating the various parts. There'll be a bill of materials. You can see that up here. There'll be a plate attached to the caster, and that plate will be shown in phantom lines. All the other line types should be correct. The line weights should be correct. The one thing that we are not going to be able to do using SolidWorks that complies with conventional drafting standards is to represent this hex-headed fastener right here properly in both the front view and the right side view. Since it's an actual view of a fastener, only the front view will show the true symbol for a hex-headed fastener. This is the assembly shown in an assembly file with the individual parts, and you can see that they've been placed in there with different colors, which I'd recommend so you can separate them. You don't have to open this in order to create a drawing, but it's one way to do it. So what I'm going to do is, with the drawing open, I'm going to go to the File pull-down menu, and I'm going to go to the Make Drawing from Assembly button, and that will open up. Now I've already got a drawing file because I've done this a couple of times. I'm going to open up a blank sheet instead. Now, because I've chosen B size as my default sheet size, it opens up automatically. Get a little palette on the right hand side that shows me my various views. I'd like to start not with a front view, but with a top view, because in order to do a section, you need to show the view that the cutting plane line goes through. Once we have the top view in place, we'll just stop, because at this point, we're going to put a section view on here. Now, in order to do the section view, we have to do a couple of things. The first, because I really don't want this view as part of my drawing, is I'm taking that view and I'm just going to move it off the sheet itself, which might seem a little odd, but I'm really using it as a source for the front view. And then I need to indicate where the cutting plane lines are going to be. By drafting convention, a full section through an assembly generally moves fasteners into the plane for the cut, even though they aren't physically there, just to for clarity. In SolidWorks, we can't put a full section through here and say move those. What we have to do instead is what's really known as an offset section. We have to start that offset section by drawing a line. The line is going to be the representation of the cutting plane line. I'm going to start it here and come out through and then come back. In order to see what's going on below, I'm going to switch my display style over here on the left from the solid display to the hidden display. A little bit confusing, but you can see we can see all of our parts there. Now I'm going to go to the sketch option. I'm going to sketch a line. I'll track off the center of this fastener. Start the line here. Just go past the fastener a little bit. Come down and find a midpoint that I can track from. See, I've got that midpoint now. Come through it. Go just past it here. Move up. Highlight over the center, track off of that. Once I've tracked off of that, come across here, and that indicates where that cut line is going to be. Now, I need to select those lines. Hold the Control key down, select each one of the lines so that they're selected as a group. So the whole point of the Control key is just to hang on to be able to get all the lines, and you'll notice they're all listed over here. Once they're listed, we go up here, View Layout, and we want to pick section view. You notice that the lines, the arrows are pointing down. We don't want them to go down, we want them to go up. And because it's a full section and you don't section fasteners and you don't section things like shafts, we're going to go into this Exclude Components window and we're going to start picking things to exclude. First thing I'm going to exclude is the bolt. The next thing I'm going to exclude is the washer that's under the bolt. And there's a nut down there I'd like to exclude, but I can't reach it from this view, so I'm going to wait until later and add it. We'll do auto hatching, which is going to help us a little bit with the hatching that's put in. We can't exclude fasteners because these fasteners were not added as actual fasteners, they were added as individual parts. And we'll do a don't cut all instances, but not yet. We'll get to that in just a second. Pick OK, zoom back out, and I'm just going to bring that view down here and put it in the center. Now I'd like to use the sheet a little more effectively, so I'm going to take this view, bring it down, and I'm going to change the scale. I'm going to select the view, go over to the left panel again. I come down to the scale window. It says Use Parent Scale. Well, parent scale means the scale set for the sheet, which happened to be 1 to 2. I'm going to change that to Custom Scale, change it to 1 to 1, and you'll notice just for that view it's shown as 1 to 1. Now, we zoom in a little bit and you can see that my bolt is not shown, the nut is sectioned, the washer is not sectioned, and I neglected to take the axle out of this picture. So what I need to do is to add those things. Before I do that though, I'm going to pick that view, change back to solid so that it begins to look a little better. Convention is not to section that axle, so we're going to take it out of the picture. Once we have the section view, in order to do that and remove elements, we need to select the view, right click, and then pick properties. One of the properties we can change is section scope. Highlight the area now, and now I can go in and select the axle. You can see that it's caster sub and then axle. And I'm going to select that nut right there, that nut right there, and I'm saying don't cut for all instances on the nut, don't cut for all instances on that nut. Pick OK, and you can see we're starting to get a little closer, although apparently I forgot to pick that bolt too. So let's go back in, properties, section scope, and we'll add that bolt in as well. So now we're beginning to get a little closer to what an actual section would look. A couple things we need to do here before we start dealing with the section lines themselves. And one of them is to eliminate these tangent lines. By default, SolidWorks will display tangent lines. We don't want to see them, so we right click on the view, tangent edge is removed. So now it cleans that part up for us. The other thing we don't want to see is these lines right here, and those lines are actually the corners of our cutting plane. It's projecting those corners down right there. Well, we don't want to see those corners in a section view because they don't actually exist. So hold the control key down, grab each one of those lines, come over here and grab each one of these lines, and then I'm going to right click on the line, and we'll go down and pick hide edge. Now those edges are out of the way and we're getting a little bit closer. Notice that I neglected to pick that washer there as well. Let's right click, go to properties, section scope, and then we're going to go in and grab the washer and put it in place as well. Don't cut all instances. Now that washer looks pretty good. Now take a look at the section lines. Section lines are correct for this top plate, that's steel. They're correct for that plate, which is cast iron, but they're not correct for the axle supports because the symbol shown is the bronze symbol. They're also not correct for the bushings because the bushings are bronze and need the bronze symbol. The other thing is, you notice that the angle for both axle supports is in the same direction, which is improper because they are two separate parts. This would imply that there is one component that has been sectioned and is connected in some way, like it may be the cylinder walls from something that continues all the way around. So we need to change the angles here. We need to change the angles here. We need to change the type of section line as well. And to do that, I'm going to select the section, come over to the left-hand side. What we can do over here is to clear the material crosshatch. In other words, we're going to clear what the defaults are. And we'll use a hatch pattern, but instead of bronze and brass in this case, we'll go up and pick ANSI 31, which is a standard iron section line. And we'll leave that one at the angle that it's set for, and then come to the other side, pick that one, do the same thing, where we change the pattern to ANSI 31. But I'm also going to change the angle to 90 degrees, so it goes in the other direction. So now the angle of 90 degrees makes this, didn't work. Let's go back and do it again. So we want to change 90 degrees, flips the angle, and that's what we want to see is opposite directions. I'm going to do the same thing down here. I won't bother to do it on the video since you've seen it. I'm just going to pause to do that. And I'm back, having just changed the material here to bronze. Now what I'm going to do next is I'm going to change the angle of this line. This angle is incorrect on this one, so I'll go down and change that to 90 degrees again. And one of the things you might want to do is change the scale, in which case I can take that number right there and maybe make it 1.5. And you'll see what happens over here as the lines get a little closer together when it's 1.5, if you do it correctly, and actually make it 1.5. Press the Enter key. And then let's go back over here. We'll do the same thing on this side just to make them consistent. So now they're both 1.5. They go in the right direction. If you look at the plate, though, the plate actually has these lining up directly with the axle support, and they can't do that. Otherwise, it appears to be the same parts. We'll make a change to that one as well, and the only change we'll make here will be the angle. I'm just going to set that to 15 degrees just to shift it a little bit. Once I've shifted that way, I'm going to grab this one up here, and I think I'm going to switch that one to 90 degrees so that it goes in the opposite direction. It's already set up for steel, so we're all set there. I'll do one more thing in this video, which is change these lines to phantom lines, and then I'll create a separate video showing you how to do the bill of materials. In order to change these to phantom line, I'm going to select that line, hold the control key down, select this line, right click, and I'm going down here to the component line font. Now these are called fonts in SolidWorks as opposed to line types. But what we're going to do over here is instead of using document defaults, I am going to, for those two edges, make them phantom lines, and I'm going to change the line thickness to 0.09. Okay, come back out. What you'll see is we've got now a phantom line. Phantom line could be a little bit thicker, and that's because actually that's pretty good thickness, but what we need to do is to change the visible lines so they're a little bit thicker. Change the visible lines. I'm going to change the document properties. To do the document properties, you need to go to Tools, Options, Document Properties, and we're going to change the line font for the entire document so that all visible edges, instead of being 0.009 inches, we're going to change it to 0.027 inches, which is approximately 0.5 millimeters. We come out now and you can see that we've got fairly thick line weights. Possibly a little too thick. We'll maybe make one more change to that. I'll get them a little bit thinner. And so what I've done here is change them to 0.5. I made them a little too thick before. That'll be it for this video, and what I'll do is make a second video that talks about the bill of materials and how to make the balloons.